Hello everybody, welcome back to my channel and welcome back to yet another exciting content on Technovation. The entire IT industry is talking about AI today. The corporate giants are busy fine-tuning models to bring the best out of them, and engineers like you and me are busy playing with chatbots, AI bots to solve use cases. That brings us to the topic for this evening. We're going to talk about a little bit of AI. Now, we're not going to talk about a hello world content. We are not going to learn AI from the bottom up. We will take a different route altogether. We will take a use case which is very, very common, which all of us can resonate with, and we will try to see how we can solve that particular use case with AI. To be precise, AI agents. I'm not going to talk about what AI agents are. I'm sure you must have already looked at tons of videos which are available over the internet, which beautifully explains what AI agents are. What we will do is, we will straight away dive into the use case, understand the different problem statements or the parts of the problem statements, and we will see how we can build an efficient agent to address those. Fair enough. What's the use case for this evening? We're going to talk about an employee leave management system. If you're from the corporate world, I'm sure you will be able to resonate with this particular use case quickly. However, if you're a student listening to this, I'm sure you will also not find too difficult to understand this use case. Now, me as an employee, I do have some questions almost every quarter. What is my current leave balance? How many sick leaves did I accumulate this quarter? How many sick leaves am I left with for the current financial year? Will I be able to carry forward my unearned leaves to the next year? Or maybe another type of questions which is more from the policy. How many earned leaves can I accumulate over a period of time? What is the formula using which I can encash some of my earned leaves? So you can understand there are two parts to this problem statement. A part which can be solved by the structural data. For example, many of you would have worked on systems like SAP modules of leave management, employee management, or maybe systems like Workday. Now in the back end, they all use a database. I really don't know what database Workday uses in the background, but I'm assuming it will be an RDBMS. And this is all structured data. Number of leaves left, type of leaves, they're all accumulated over a period of time and they are stored in your corporate databases. Very similar to that, another type of problem statement which is not there in your structured information, but they are a part of your policy document, which is your unstructured information. Now, I'm going to build a bot which is going to cater to both these requirements together. Am I going to ask the user to click on a button saying that press 1 for structured data information or press 2 for unstructured data information? No, there will be no IVR to guide you to that. It is the LLM which is going to understand the problem statement or the ask from the user from the prompt and take actions accordingly. Let's talk about the tech stack a little. I'm using OpenAI. I'm using OpenAI Python SDK for communicating with OpenAI and getting this done. Why did I use OpenAI? Because I found it a little easy to start with. Can I not use anything else other than OpenAI? Absolutely yes. There are so many stacks like LangGraph, LangChain, Crew AI in the open source market, and you can use it. As a vector store, what am I using? I'm using OpenAI Vector Store. Can I not use something else? Absolutely yes. The freedom of choice, the freedom of technology choice is yours. But for this particular demo, I have chosen OpenAI just as a startup. Maybe as I think about an upgrade, I'm not going to pay OpenAI for every API call that I make. Maybe I'm going to host some agent freely on my local machine, maybe a small LLM, maybe a small SLM. Let's see how it moves. But for now, let's focus on the use case and let's get it done. Enough of talking. Time for some action. Let's head over to my VS Code and see this particular in use case being solved with OpenAI SDK in Python. Before I head over to my VS Code, a gentle request as always. If you are new to this channel, please do not forget to subscribe, and if you like this kind of content, I will be super happy if you press the like button. Tiny gestures like this from audiences like you makes a lot of impact on our motivation. Thank you very much. See you in the next section of the video.
This brings us to our favorite editor. Here is the code base, but before I take you through the Python file, let me show you the blog that I was working on. Right. So this is the Medium blog which has already been published. The video that I am recording right now will be appended to the end of it. What I've done is I've tried my best to elaborate the particular use case wherein the AI bot is instructed to serve the prompt both from the structured and the unstructured data. Let me enlarge the screen a little bit. Here is a rough idea about the leave assistant. So the employee is talking to the leave assistant, and the assistant has two primary processes. The first process looks up the employee leave database, and the second process looks up the employee leave policy document. I've also mentioned some of the sample queries like, can you share the earned leave balance for my employee ID? Now the employee ID is very important out here, that being the primary key to uniquely identify a particular employee. What is the maximum number of leaves that can be carry forwarded? I mean carry forwarded from the current financial year to the next financial year. How much will be my total leave encashment amount if I sell them? Fair enough. Let's go to the actual agent, ask these questions and see the response for ourselves. Moving forward, so this is the pattern that we have implemented out here. If you refer to the Anthropic blog, it clearly calls out a router pattern wherein the router decides that which is that particular tool. So here every function is called a tool, which is that particular tool that the router is going to invoke based on the questions asked in the prompt. I would also like to take a look at the program structure. So what I've done is I've created a very basic program structure. The first is you have the get leave balance function. This is acting as a tool to pull the data from your employee data database. Now here employee data is a JSON file. However, maybe in the second iteration of this particular project, we are going to replace employee data JSON file by a typical API call to the database where the data is hosted. This particular function returns three variables. The first one is earned leaves, the second one is sick leaves, and the third one is the basic salary. Now, who invokes this particular function? This function is invoked by your leave balance agent. As you can see, here is the signature of the agent, wherein under the tool section we have called it out that the tools equals to get leave balance, which is equal to this, right? The next agent is the policy search agent, and the policy search agent uses the default tool, which is file search tool. Now this is not a custom tool, this is a very default function that OpenAI Agent SDK provides you. We just need to provide provide the details of the vector search. We will see that when we go to the code. And here is the triage agent, which actually acts as the router between these two agents. The triage agent receives the user prompt, it evaluates the user prompt, and it decides which is that particular tool it needs to invoke. Let's go to VS Code. Okay, so I've already uploaded the code here on the GitHub repository. So under AI agents, if you go to leave_management, you will see these three files, right? So here's the employee data that I was talking about. So there are 5 records. Don't worry, this is again nothing confidential. I have requested GPT to generate this data and it did a brilliant job. So there are 5 records, E101 to E105. It has information like basic salary, earned leave and sick leaves. The leave balance agent, there's a little bit of instruction. Now the instructions, what I found is the instruction is very important for the triage agent to rightfully identify which agent to invoke, because it's all NLP in the background, right? So the more clear you are with your set of instructions, the better it is for the agent to decide. In the policy agent, you can see that there's a vector store. Now how did I create this vector store? You can see there's an employee leave policy document out here. Employee leave policy document. Here is a policy document. Again, I have used GPT to create this particular one. It talks about the various types of leaves. It talks about the leave encashment policy, the leave encashment calculation, and it also talks about some of the, leave accrual and leave carry forward policies. Moving forward, what I've done is I have taken this particular document and I have uploaded it to the OpenAI dashboard vector store. So on the OpenAI dashboard, I have a vector store wherein I have uploaded this particular policy document, and here is the ID that we are going to use. Now I could have used a fancy vector store like ChromaDB or anything like that, or maybe Snowflake vector store, vector data types, but then I thought this is the easiest way to get it started, and hence OpenAI vector store is the one that I have used. Here it is. Quickly moving forward. Right. So let me close this. Maximum number of results, because this is set to 1. I really do not want to confuse the user or the employee who's talking to this particular agent, because the moment you make this number greater than 1, there will be multiple responses and you will have to choose the best. Triage agent is the agent which actually does the router. So if you can see, the instructions are very neat and clean here. If the user is asking for a specific leave balance, please route him to the leave balance agent. If the user is asking for policy details, please route him to the policy search agent. Here is the main function, and then finally you are just invoking the main. Let's go ahead and run the results and see it ourselves. So what I'm going to do is, the first 2 are uncomment. Let me uncomment them, and I'm going to comment the third one for the time being, because too many results together is not going to be a nice way to look at it. So let me go ahead and run it. Oh yes, I'm executing it. The first agent is running. I think it has also kickstarted the second agent. So running the agent, my employee ID is E102. How many leave balances do I have? I have 15 leave balances. Let me verify the answer once. E102, yes, it E102, and it has 15 leave balances. Let's go to the other one. What is the next question? The next question is, how is the leave balance or the leave encashment calculated as per policy? And you can see it has pulled up the entire policy document out here. Let's go ahead and verify it from the policy document. If I go to the policy document, I think there it was. Yes, you can see exactly this is the statement that it has copied from the document and pasted on the output. Leave encashment, number of leaves encashed multiplied by basic salary per day. Now I really don't know whether it is right or wrong, but then the LLM was instructed to use this policy document to answer this question, and it did the right job. leave encashment amount equals to number of leaves encashed times basic salary per day. Fantastic. Okay, now what I'm going to do is I'm going to comment out the first two questions and I'm going to run the second one. Let me go ahead and clear the screen and I'm going to run it. Now the second question is a little bit tricky. The second question says, my employee ID is 1050. Please find my earned leave and basic salary. Once you have it, please calculate my leave encashment amount. Now, definitely 1050 is not there because the last employee ID is 105 that we have in our employee database. However, I'm asking it to find out the employee information about 1050. So it's very smart enough in saying that it seems if you have your basic salary in advance, I can calculate it for you. It seems I am not able to retrieve your information. So did a great job again. Now I'm going to give me a moment. This is a little tricky. I'm going to change this. I'm going to make it 105. Right? Let me clear it and let me run it again. While it runs, let me pull out the information manually from the database. For 105, it's 55,000 and it's 11. Oh, wow. I think it is able to find out. Something is wrong, right? Okay. I changed the print statement, but I did not actually change the prompt. My bad. I'll have to run it again. Okay, there you go. My employee ID is 105. Your earned leave balance is 11, right? And what was the salary? The salary was 55,000 and it has rightly pulled the number 55,000. So 55,000 divided by 30 and then it multiplied it by number 11 and the total value is 20,000. 20,166. So you can understand what it did, right? So if I go to my solution architecture diagram again, it received the prompt. The agent was intelligent enough to understand that there are two parts. First, I'll have to go to the leave database and pull the basic salary and the leave information, and then I'll have to apply the basic salary and leave balance information on the formula that I retrieved from my policy document. It was a two-step process and the engine was able to deliver the results successfully. Right? This brings us to the end of the video, but then I'm going to leave you with some food for thought. Let me head back to my blog wherein I have captured what's next. This is a very bare bone agent that we have built right now. We definitely need to improve it further. So how do we do that? Maybe test it with some open source models. This will make the entire initiative cheaper. I'm not sure whether it will be faster or not, but it will definitely be cheaper because I'll not have to pay OpenAI for every OpenAI request that I make. Replace the OpenAI SDK with an open source framework, maybe LangChain or LangGraph or Crew.ai. Replace the data dictionary that we use, right? This particular data dictionary I'm talking about, with an actual backend database. Maybe I'll be using something to do with text to SQL. Let's see what I can do. And the last one is apply agent guardrails. Now, agent guardrails, to a certain extent, OpenAI today is smart enough to apply the guardrails on its own. Like, for example, the employee ID that we provided, 1050, it never existed and it was smart enough to deny further processing, saying that the employee ID itself doesn't exist. Now, what if you ask something to this particular leave management system about, let's say, some subject? Let's say you are asking a question about physics. Let's say you are asking some questions about general computer science. The agent is not designed to do that, and that is where your guardrails will come into the picture. Once we apply the guardrail, it is going to deny the question even before it reached the router. Brings us to the end of the video. If you're super curious about it, please take a shot. Try to download this code, execute it, experiment with it, build the next steps. And if you are really successful, I'll be super happy to hear about your experiment in the comment section. For being a lovely audience, if you like this kind of content, please hit the like button because this motivates the content creator like me a lot. Thank you once again and see you in the next lecture. Bye-bye.